Welcome back, everyone. I am so thrilled to have you here for this explainer, because today we're jumping right into a totally fascinating, incredibly high-stakes scenario. I want you to literally imagine you're sitting down at a massive, state-of-the-art console. You are a human operator, and you've just logged in to WARDEN ELECTRON. Now, this isn't your standard, run-of-the-mill IT monitoring job. Not at all. This is the absolute cutting edge of AI governance. We're going to walk through a day in the life of this operator, really exploring how we maintain control over highly advanced, autonomous systems that are operating across vast digital and physical spaces.
Now, there's a core philosophy that drives WARDEN's entire architecture, and it's this: visibility does not automatically equal authority. That one single sentence, that is the beating heart of your job at the console. Just because an AI system can see and process a massive amount of data across a network, well, that doesn't mean it should automatically be granted the power to act on it. Your immense responsibility as the operator is to act as the ultimate judge. You are standing firmly between what the AI observes and the authority it's actually allowed to execute.
Section 1. The Cyber Command Shift.
So, picture yourself settling into your chair. You aren't just staring at passive dashboards waiting for a red light to blink anymore. In the old world, traditional monitoring asked incredibly shallow questions, right? Things like, is the server online? How much CPU is being used? But you, the modern WARDEN operator, you're tasked with answering deeply behavioral, highly contextual questions. Things like, should this specific node be trusted at this exact second? Or, is its current behavior actually consistent with its established identity? You are no longer just checking the pulse of a machine. You are evaluating the trust and intent of an intelligent system.
Section 2. Inside the Awareness Matrix.
To answer those deep questions, you're going to look directly into the Awareness Matrix. This is the central hub of the WARDEN ELECTRON interface. And just notice the sheer breadth of live data streams you're evaluating here. You aren't just seeing one blended binary score. You are looking at fleet trust across the entire network. You're gauging the AI's decision confidence and checking for cross-signal agreement. Basically, are the different sensors even telling the same story? You can monitor active decoys that are deployed to confuse adversaries. And most importantly, you manage the queue of human approval requests. You're constantly feeling the pulse of the AI fleet's behavior, so you can step in before any premature autonomous action is ever taken.
But to truly understand these signals, you need this one crucial concept: spatial context. As the operator, you aren't just looking at isolated, floating data points. It's like a giant puzzle. You're using the awareness matrix to understand the critical relationships between entities. How does an AI agent relate to an API? And how does that API connect to actual physical infrastructure, like a robotics facility? You see? A network event might look totally harmless in isolation, but when you spatially correlate it with a robot moving into an unauthorized physical zone, well, the entire picture changes.
Section 3. Funneling the evidence.
Right as you're observing those complex spatial relationships, bam, a red alert flashes. The tension spikes, right? Your workflow instantly shifts from broad observation into laser-sharp investigation, using the inverted triangle workflow. The system takes a massive, noisy observation surface at the top and funnels it down. First, it observes the vast network. Second, it correlates those spatial and digital signals we just talked about. Third, it reduces the evidence, filtering out the noise while keeping the context. Fourth, the AI makes a recommendation. And finally, the funnel reaches its absolute narrowest point at the bottom. Step 5, authorize. That's you. WARDEN filters this massive ocean of data into a narrow, evidence-backed decision funnel just for you to evaluate.
So the really crucial point here is how WARDEN handles imperfect data during that funneling process. It brilliantly does not manufacture fake certainty. It actually preserves contradictions. If one sensor says a node is safe but another detects behavioral drift, WARDEN doesn't hide that conflict behind a clean, blended score. No way. It surfaces the disagreement, the exact provenance of the data, and the confidence levels directly to you. It treats these contradictions as crucial, messy evidence that requires actual human reasoning to untangle.
Section 4. Trust in Temporal Context.
As you dig deeper into the conflicting evidence of this alert, you run into your next major challenge: time. To ensure you aren't making a critical decision based on stale data, you use the real-time factor, or RTF, workflow. You are constantly asking the system, how recent is this specific signal? Has the environment changed since this data was collected? Have newer observations appeared that completely contradict the older ones? In your world at the console, the operational value of a fact decays by the millisecond.
And this brings us to a terrifying reality if it's left unchecked. Trust is temporal. An identity can be completely valid one second and utterly compromised the very next. A machine can be perfectly healthy and a moment later begin to drift. If you don't continually reassess the temporal context, old, outdated observations can quietly harden into permanent, dangerous assumptions. Your vigilance here? That is exactly what keeps the network secure.
Section 5. The human in command.
Okay, the evidence has been reduced, the spatial and temporal contexts have been evaluated, and the AI has officially recommended isolation. The workflow has reached its climax. But before you push any buttons to make the call, you perform a black box audit. Think of a commercial aircraft, right? The black box is crucial because understanding how a system reached a state is just as important as controlling what happens next. So you look at the timeline. At T-3 seconds, the AI observed the anomaly. At T-2, it correlated the spatial drift. At T-1, it formulated the recommendation to isolate. And now, in the present, you are reviewing this exact chronological chain of reasoning. You aren't just blindly trusting the machine, you are auditing its logic, step by step. And this brilliantly illustrates the control you yield. This is the Action Menu button panel on your console. You've reviewed the AI's black box logic, you've weighed the evidence, and now you execute what the source calls governance dominance. You have a highly nuanced vocabulary of actions. Are you just going to observe? Will you challenge the behavior? Maybe route the attacker to a decoy or execute a sinkhole maneuver? Or will you take the AI's recommendation to isolate? You click your choice, firmly asserting human authority over the autonomous system.
When you finally step back from the console, this is the core takeaway of everything we've explored today. As the source material explicitly states, the goal is not autonomous security theater. The goal is controlled autonomy with an operator still in command. Honestly, no matter how fast, how capable, or how advanced the AI collective becomes across physical and digital space, the human operator remains the ultimate, indispensable backstop.
I want to leave you all with this highly provocative final thought directly from the source. As AI gains more tools, more access, and more independence, the question is no longer just, what can the AI do? The real question is, who is watching what the AI does? What does the system believe? And who still has the authority to stop it? I really hope this explainer has given you a compelling look into that answer. Stay curious, keep learning, and I'll see you in the next one.